Hello students, class 12, chapter is alternating current, topic is LC oscillations. LC oscillations के अंदर हम एक चार्ज कैपेसिटर को इंडक्टर के साथ ज्वाइन करते हैं। इनिशियली कैपेसिटर पर हमारा चार्ज प्लस क्यू नॉट एट टी इज इक्वल टू 0 and at this time the current in the circuit is 0. Therefore, the magnetic field energy stored by the inductor is 0. Because you know the energy, magnetic field energy stored by the inductor is half Li square. Therefore, when current I is 0, therefore magnetic field energy stored by the inductor is 0. But at this time, the charge on the capacitor is maximum. Therefore, energy stored by this capacitor is maximum. Because you know the energy stored by the capacitor is, this is U is equal to electrical energy is equal to this Q square upon 2C. So this is the situation at time t is equal to 0. But slowly this capacitor starts discharging, and at t is equal to t by 4, the capacitor gets completely discharged. That is, charge on the capacitor Q is equal to 0. And at this time, the current in the circuit is maximum. Therefore, the energy stored by the inductor UB is equal to maximum and UE is equal to 0. The energy, electric field energy is 0 because at this time charge on the capacitor is 0. Therefore, here the magnetic field energy is maximum and here this electric energy is 0. But at the next instant, this capacitor again starts recharging. And at t is equal to t by 2, capital T by 2, the charge on the capacitor is again maximum with opposite polarity. Capital Q is equal to minus Q naught with opposite polarity. Therefore, energy stored by the capacitor is again maximum and the energy stored by the inductor is 0 because at this time current I is equal to 0, right? But at the next instant, this capacitor again starts discharging. Therefore, at time t is equal to 3t by 4, the charge on the capacitor is 0. Charge on the capacitor is 0, and hence the energy, electrical energy stored by the capacitor is 0. And at this time, current is maximum. Therefore, the magnetic field energy stored by the inductor is maximum at this time. Therefore, here हम देख रहे हैं कि यहाँ पर जो एनर्जी है, दिस एनर्जी, इलेक्ट्रिकल एनर्जी एंड मैग्नेटिक एनर्जी ऑसिलेट between this capacitor and inductor, right? This case is same as this. Suppose a block is attached with a spring, and this block is stretched or displaced through some distance like this, and here the energy stored by the system is here. This energy is potential energy is maximum. Potential energy of the system is maximum because this is extreme position and this is here mean position, right? Now here potential energy stored by the spring is maximum and the kinetic energy of this block is 0. But at the mean position of the system or this block, the kinetic energy is maximum, and the potential energy is 0 at mean position, right? तो हम यहाँ पर देख रहे हैं पोटेंशियल एनर्जी हमारी मैक्सिमम और यहाँ पर आकर पोटेंशियल एनर्जी 0, तो यहाँ पर पोटेंशियल एनर्जी काइनेटिक एनर्जी में कन्वर्ट होती है और काइनेटिक एनर्जी फिर पोटेंशियल एनर्जी में कन्वर्ट होती है. तो सिमिलरली हियर आल्सो इनिशियली इलेक्ट्रिकल एनर्जी कन्वर्टेड इनटू मैग्नेटिक एनर्जी एंड दिस मैग्नेटिक एनर्जी कन्वर्टेड इनटू अगेन इलेक्ट्रिक एनर्जी एंड दिस कन्वर्टेड अगेन इन magnetic field energy. So here total initial energy of the system oscillate between capacitor and inductor, and if there is no resistance in the circuit, That is, here the capacitor is pure capacitor and inductor is also pure inductor, that is no resistance in the circuit, then no loss of energy during LC oscillations, and we obtain a constant amplitude oscillation, and such type of oscillations are known as undamped oscillations, and these are represented by, here the amplitude of the oscillations are constant or remains constant with time. So here we obtain undamped oscillation when total energy oscillates between this capacitor and inductor. Now, here we want to calculate the frequency of such electrical oscillations. Expression for the frequency of electrical oscillations, जो हमारे यहाँ पर चार्ज के ऑसिलेशंस हो रहे हैं, उन ऑसिलेशंस की फ्रीक्वेंसी हमें चाहिए. तो फ्रीक्वेंसी के लिए हमने लेट किया दिस कैपेसिटर विच इज इनिशियली चार्ज एंड हैव मैक्सिमम चार्ज वैल्यू Q नॉट and this inductor L, right, at t is equal to 0, no current is flowing, that is I is equal to 0 at t is equal to 0, and when this circuit is closed, the charge on the capacitor decreases, means some current is also flowing in the circuit. जैसे इस सर्किट को क्लोज करते हैं तो ये कैपेसिटर हमारा डिस्चार्ज होना शुरू होता है और सर्किट में करंट फ्लो होना शुरू होता है. हमने सपोज किया Q बी द चार्ज एट एनी इंस्टेंट. सर्किट को क्लोज करने के बाद किसी इंस्टेंट पर कैपेसिटर पर चार्ज हमारा कैपिटल Q, राइट, एंड एट दैट टाइम करंट इन द सर्किट इज आल्सो चेंजिंग, and due to which induced EMF will produce in the inductor, and that induced EMF is equal to, E is equal to minus L di upon dt. सर्किट को क्लोज करने के बाद जैसे ये कैपेसिटर डिस्चार्ज होना शुरू होता है तो सर्किट में करंट फ्लो होती है तो इस इंडक्टर के अंदर इंड्यूस EMF प्रोड्यूस होता है. दैट इंड्यूस EMF इज गिवन बाय E is equal to minus L di upon dt, right? Now using Kirchhoff's loop law, this here potential across capacitor Q upon C, and here the potential difference across this inductor is minus L di upon dt. So potential across this is equal to 0. Here we are using Kirchhoff's voltage law. So according to this, potential across capacitor and this is potential across inductor is equal to 0. And here the charge on the capacitor decreases with time. Therefore, current increases in the circuit. जैसे जैसे चार्ज हमारा कैपेसिटर पर चार्ज डिक्रीज होता है तो सर्किट में करंट की वैल्यू इंक्रीज होती है. And hence this I is equal to minus dq upon dt. This I is equal to minus dq upon dt, right? Now from equation 1, that is putting the value of this I here, therefore we get this Q upon C plus L into d square Q upon dt square is equal to 0. I की वैल्यू को हमने इक्वेशन नंबर 1 में प्लेस किया. Therefore d square Q upon dt square plus half, this is 1 by LC into Q is equal to 0, because हमारा तो यहाँ पर Q upon C into the plus L into d square Q upon dt square is equal to 0. तो हमने इस इक्वेशन को रीअरेंज किया. this is d square Q upon dt square plus this 1 by LC into Q is equal to 0. Now on comparing this equation with the standard equation of oscillations, this is d square x upon dt square plus omega a square x is equal to 0, right? Here this x is this displacement through which this block is displaced, right? This displacement, as you know, energy is stored by the spring is half kx square, right? And the equations for differential equation of simple harmonic motion is this. Therefore, on comparing this equation with this equation d square x upon dt square plus omega square x, now here we get omega square is equal to 1 by LC, or this omega is equal to 1 upon root LC. But you know this omega is equal to 2 pi nu. Therefore, this is 1 upon root LC, or nu is equal to 1 upon 2 pi root LC. This is required expression for frequency of the electrical oscillations. Frequency of the electrical oscillation. हमें यहाँ पर इस इलेक्ट्रिक सर्किट के, ये इलेक्ट्रिक सर्किट मीन्स कैपेसिटर, a fully charged capacitor is connected with this inductor, and when the circuit is closed, the charge oscillate and hence the energy oscillate between the capacitor and inductor, and hence there is some frequency of the oscillations of the energy or the charge, and that frequency of the oscillation, electrical oscillations, is given by nu is equal to 1 upon 2 pi root LC. This is required expression for the frequency. Now, the variation of the charge with the time is given by capital Q is equal to Q naught into cos omega t. The charge on the capacitor at any instant, the charge on the capacitor, right, at t is equal to 0, charge on the capacitor is 0, charge on the capacitor, this is plus Q at t is equal to 0, right. Now put here t is equal to 0, and this is cos 0, and cos 0 is 1, and therefore charge on the capacitor is maximum. Therefore, the variation of charge is given by only this equation or only this relation. Here we cannot use Q is equal to Q naught sin omega t. हम यहाँ पर यूज नहीं कर सकते Q is equal to Q naught sin omega t. This Q is equal to Q naught sin omega t, because at t is equal to 0, charge on the capacitor is 0, but initially we consider here the charge on the capacitor at t is equal to 0 is maximum. Therefore, the variation of the charge with time is given by this relation only. Capital Q is equal to Q naught into cos omega t, and hence on differentiating this equation with time, then I is equal to minus dq upon dt, and this is I naught into sin omega t, and this minus sign indicates that the value of charge on the capacitor decreases with time, and hence current increases in the circuit. Now, this is the variation. Now, next point is energy conservation during the LC oscillations. हमें प्रूव करना है यहाँ पर कि टोटल एनर्जी ऑफ द सिस्टम रिमेन्स कांस्टेंट ड्यूरिंग एलसी ऑसिलेशंस. हमने सपोज किया लेट दिस क्यू बी द चार्ज ऑन द कैपेसिटर एंड द आई करंट फ्लोइंग इन द सर्किट एट एनी इंस्टेंट. किसी भी टाइम पर हमने सपोज किया कैपेसिटर पर चार्ज हमारा क्यू है और उसमें सर्किट के अंदर करंट आई फ्लो करती है, राइट. देन हम उससे पहले हमारा इनिशियल चार्ज कैपेसिटर का क्यू नॉट था. इनिशियल चार्ज हमारा कैपेसिटर का क्यू नॉट. एट दिस टाइम द टोटल एनर्जी ऑफ द कैपेसिटर is maximum, and this is U naught is equal to Q naught square upon 2C. This is the maximum energy stored by the capacitor at t is equal to 0, and at the same instant energy stored by the inductor is 0. Energy stored by the inductor is 0. Therefore, total energy of this circuit is only electrical energy, and which is equal to U naught is equal to Q naught square upon 2C. तो हमें यहाँ पर प्रूव करना है किसी भी इंस्टेंट पर टोटल एनर्जी ऑफ द सिस्टम शुड बी इक्वल टू दिस. देन लेट Q instant मतलब at any instant t the charge on the capacitor is Q and the current I in the circuit, then the energy stored by this capacitor is Q square upon 2C. इस इंस्टेंट पर एनर्जी स्टोर्ड बाय द कैपेसिटर इज क्यू स्क्वायर अपॉन 2C, एंड एट द सेम इंस्टेंट द एनर्जी स्टोर्ड बाय द इंडक्टर इज हाफ Li स्क्वायर half Li square, right? Therefore, the total energy at any instant U is equal to this UE plus half UE plus this is UV. Total energy UE plus UV, that is electric energy plus magnetic field energy, and this U is equal to Q square upon 2C, right? And this UV is equal to energy of the inductor is half Li square. Therefore, on putting the value of this is Q is equal to आपका हमारा क्या था यहाँ पर, this is Q naught cos omega t. Put here value of Q. This is Q naught cos omega t, and the current in the circuit is this. I की वैल्यू हमने रखी यहाँ पर, इसका डिफ्रेंसिएशन करते हैं तो दिस इज माइनस क्यू नॉट इंटू ओमेगा इंटू साइन ओमेगा टी. On differentiating this Q, we have the value of I, and this is minus Q naught into omega into sine omega t. On squaring this, right? Now this is Q naught square upon 2C, and this is cos square omega t plus this half into L, this Q naught square into omega square into this sine square omega t, right? And this U is equal to Q naught square upon 2C. Here this as it is cos square omega t plus this half into L Q naught square into this omega square हमने किया था, this is 1 upon LC. This is here omega square is equal to 1 upon LC. Therefore, on putting this value of omega square, this is 1 upon omega square means 1 upon LC, right? And this is as it is sin square omega t. This L cancel by this. Therefore, on taking common Q naught square upon 2C, this is here cos square omega t, and here the sin square omega t, and you know this is equal to 1, and hence this energy at any instant is Q naught square upon 2C, and this is initial, this energy is equal to initial energy stored by the capacitor, which is U naught, and hence the total energy remains constant during the LC oscillations. यदि हमारे सर्किट में इस सर्किट के अंदर कोई रेजिस्टेंस नहीं है तो टोटल एनर्जी हमारी टोटल